Hello there. Good morning, everyone. Uh, my name is Yuri Chamarelli, and today we're going to be talking about Plcnext Edge Gateway. Just a quick reminder that this presentation has a 20 seconds delay from when you guys are actually watching it. So if you have questions, just bear with us. And I have Ken Austin with me over here, and he's going to be helping on the Q&A. So just hold your questions, send into the chat as you like it, and we are going to address them all, okay? So first of all, let me do a quick introduction of myself over here. So for those who don't know me yet, my name is Yuri Chamarelli. I'm the lead product marketing specialist for control systems, okay, and also edge computing. So all the PLCs, the software that goes with PLCs, and also the Linux cloud applications around PLCs, it's my domain. So if you guys have any questions related to those topics, please feel free to save my email address and reach out to me through that, or you can find me at LinkedIn as well and add me, and we can discuss about anything you guys like to discuss. All right. So the presentation today is, a continuation to the network infrastructure automation series. And as you guys know, when you talk about network infrastructure these days, we need to think about IoT. It's not just about having a local on-premises network anymore. We also have connection to the web. That data we are collecting within the manufacturing floor or a single machine is going to a cloud service or is being analyzed remotely or monitored remotely by a maintenance team or a predictive maintenance team, however. So there are many ways to do that, and they are definitely part of your network infrastructure. And today we're going to tackle one of the ways we can do that, and that is by using a product that we are developed in the US. This is a fully developed application in the US, and it's called the Plcnext Edge Gateway. It is a application. You can look at it as an app, and it turns your Plcnext controller, your device, one of these, okay, into a edge computer / gateway to the cloud, okay? So the presentation doesn't have a lot of technical content on how we do that. I'm gonna get actually straight up to the screens and show you guys the configuration and all that. But that is the end goal of this product. So when you look at the diagram, we have underneath it all the drivers we support as of today: Modbus, Ethernet IP as a Ethernet IP device, so we could connect to a Rockwell controller, receive data from the Rockwell controller, and process the data. We can also connect to our own software, Plcnext Engineer. So if you have a Plcnext Engineer project, it plays all together. And we can use the local I/O, the axial line I/O that you may have in the PLC over here. Finally, we go up and we have processing capability. That's where the edge computing lives on. We can process the data, we can do if and else logic, and we can also scale, multiply the data, process, change the name, do some massage with that data before I publish to one of the connectors on the top right. So we have Proof Cloud, which is the Phoenix Contact proprietary cloud system. We have AWS, Microsoft Azure, and Google Cloud. And we also working on a Spark Plug B connection, which is going to be available in the future, right? In fact, the whole infrastructure that I'm showing you guys, it's not yet available. This is a beta product right now. We are looking for beta users. So if you like to try it, or if you have a potential customer account which could try that, please reach out to me. We're gonna take a look at it, and if it's interesting for all the parts, we can provide a beta test for this customer or Phoenix contact person. So now let me show you guys how it works. All right. Basically, the idea behind Plcnext Edge Gateway is that you do not need any programming knowledge, okay, to configure and use this application, right? You could be a OT person, or you could be an IT person who never done PLC programming before, and you will be able to configure and use this device, right? So the platform runs 100% on a web-based platform. So this is the IP address of the device, okay? I go to the IP address and I get this configuration page, okay? I log in and I start configuring my connections, okay? And I'm gonna be showing you guys around a little bit how things get together here. However, bear with me and please be patient. And all of you know that live demos sometimes they have problems, and I may fail over here, may have a bug or two that I'll run into it, but just bear with me and I'll explain to you guys everything. So as you see, we have cloud connections, we have metrics, and we have drivers, right? From the get-go, if you have IO, okay, connected to the bus, axial line will come, will turn on, and we'll show you. If you click over here, you can see what IO you have, okay? You can see the type of the IO, and you can actually watch live data on the IO. And as you can see, my analog input is going up and down, and here on change. So there you go. So the data is live. And if you have a card, a axial line card that can be configurable. So some of you know that we have analog cards that can do 0 to 10 or 4 to 20 milliamps. You can change that configuration right here. Okay, cool. Now back to dashboard. What else we have for drivers? We have Modbus, as I told you, and we have Ethernet IP. Okay, Modbus is a Modbus client, which means you are the client and they can connect to multiple servers down the line, and you cannot just read data from those Modbus registers, but you can also write data down to the server. Okay, so it's a full-blown Modbus client, and I'm gonna show you guys in a bit how it works. The Ethernet IP is a Rockwell only driver. It's a Rockwell scanner. So if you have a Rockwell master within the network, you can find the variables that are declared as external in Studios 5000 or RS Logix, whatever is the programming platform, and you can find those metrics, those tags over here, right? Tags, variable metrics, you can call them anyway. And it's also really easy to configure. You just need a name, an IP address, a slot, a scan rate, and how many times you want to try that connection before you have a watchdog crash. So it's pretty easy going. I'm not going to be showing Infinite IP today, as I don't have a Rockwell controller set it up over here. But if you guys have interest in that, I have plenty of videos and task reports that we have put together. Just reach out to me or your Phoenix local representative, and we can show you guys more. So the Modbus I will show you guys in a minute. Before I do that, let me just finish my walkthrough. So now on the right side, okay, you can create metrics, and metrics are a visual of any data from anywhere within the platform. Okay, it's just what you want to see in the screens. And you can be watching data from your local bus, you can be watching data from your Modbus driver, from your Ethernet IP connection. You could be watching data that you publish into the cloud from a metric. But most important is that metrics, they allow you to manipulate and massage, change that data somehow. So for instance, if I pick scaled, right, and then I select that for my source, I like to use my axial line modules, slot 3, which is my AI, and I wanted that channel 0 that I know I have 2.3 volts over there, right? So I select that value, and then I can come over here and do a scale tap and change the name to analog, and pick a multiplier by chance, and I can't actually multiply that value by 10 right now. Now I watch that value, instead of being 2 volts, I'm watching 21 volts, right? So those are metrics. There's a lot you can do with metrics. I'm not going to have the time to show you guys all today, but there's the reason why you have metrics over here, so you can treat your data before you send it out to the cloud. Okay. Finally, you have cloud connections, and we have, as of today, like I told you guys, we have four connections. We have AWS, Microsoft Azure, Google IoT, and ProfCloud. Okay, those are the connections that you have available. Each cloud system requires different configuration. Right. So for instance, if you're doing AWS, you got to go through these steps. If you're doing Azure, it's a little different. Okay. If you're doing Google, it's also different. For each configuration over here, if you need help setting those up, we have created guides for this. For instance, you go over here, oops, that one is not updated. But Microsoft Azure, we have a full-blown guide on how to go into Microsoft Azure, create your hub, your IoT hub, your IoT device. Then you can come back to the gateway and get your connection established. I'm going, in fact, show you guys how Microsoft Azure works today. And we also have ProfCloud, which is a Phoenix Contact brand. And that one is actually really easy. That is no configuration. It's pretty much automatic. You just hit ProfCloud and you're done, right? So now the game plan for today, I'm going to show you guys how the Modbus works. We're going to create a metric, and we're going to try publishing that metric onto ProfCloud and Microsoft Azure. Okay. So any questions so far? Are we good for now? If you want to ask any questions right now, would be a good time.
Yuri, there's no questions currently.
Good. All right. So let's configure Modbus. So Modbus driver requires a few steps, and they are pretty easy. If you ever done Modbus before, it's gonna be so easy for you. Okay, I'm gonna call Modbus test. You just need an IP address. I know the IP address of my Modbus server. Okay, it's 107 over there. You do not change the port. You do not change the timeout unless you want to change it. And pulling rates, how fast it's pulling the data from that server. By default, 500 milliseconds, which is 5 seconds. And the unit ID, I know my server is using 1. You go ahead, submit it. You wait for connection. And it's trying to connect. I hope I can connect. I have had problems with that in the past. As I told you guys, live demos are unpredictable. And I done that probably 5 times last night, and everything was working fine. And it may be the case that I'm not going to be able to show you guys today. So I'll leave that running for now. And then we're going to go to the next step on my game plan for today, which is we're going to create a metric and publish that metric to a cloud service. Okay. So first, actually, we have done that already. We created an analog metric over here from my Xline bus. Now I want to publish it to Proof Cloud. Okay, Proof Cloud, like I told you guys, it's really easy. You just select Proof Cloud and hit submit it. Okay, and of course we have an error, but as you click over here, it will tell you what it is. So the UUID of this device, it's not enabled in Proof Cloud as it is right now. So some of you may have used Proof Cloud before, but the way Proof Cloud works is just you log in and you're going to have something called the device management, and you need to add your device over here so that connection in between the gateway and Proof Cloud can occur. And the way you do that is by getting the UUID of your device. The UUID of your device is printed in the enclosure of that device, the actual housing right here. So right here says UUID right here. That's what you're looking for. Okay. So optionally, you can actually grab it from the web page, which I'm about to do.
Yuri, while you're doing that, in your previous process, somebody pointed out that that you may have typed in an incorrect IP address.
That's why it didn't work.
Thank you, Robbie.
Thank you, Rob. Yeah, that's a good point. Let's go check if he's right. Yes, you are correct. It's 68. Let's see if that fixes. All right, back over here. I want to go to Proof Cloud Services, and I should find my UUID right here. If I copy and go to Proof Cloud, add the device, paste my UUID there, and just name. Boom. Now my beta choose here is still offline. It will take a little bit but that connection will finally work. It needs a few cycles over here, but it's going to be okay. And my Modbus still trying, Rob. I don't think that was it, but it may be the case that my my server is not working properly, but we will find that out later. All right, perfect. So you see right now shows connected, and if I go back to Proof Cloud, I can see also online here, and if I keep refreshing it, eventually we'll know what it is. It's a Plcnext Edge Gateway. Okay. Now all I need to do to publish data to Proof Cloud is I go into Proof Cloud, I go into metrics, add, select a source, okay, and sources. The way we design this platform, you can grab data from anywhere at any time in any orientation. That is no limitations from where you go to select the data you want to publish to your cloud, right? So I want to publish from my logic, which is one of those scaled metrics that we created. And I know analog scaled is right there. And I can drag that and drop. And I can even give another name. We cannot change the name at all if I don't want to change the name. I just pick an interval. We're going to do that every 2 seconds. And I submit it. Okay. Oh. Let's try one more time. There you go. So now I can see on the top over there that my analog has been published 1 second ago. So it keeps publishing every 2 seconds. And in fact, if I go to Proof Cloud, I can see the metrics being published over there, right? Now, how about we go back over here and I show you guys how easy it is to do Microsoft Azure. That's actually my favorite one. So first thing, let's go to Microsoft Azure Iot and we give it a name. And how it needs to connect is something called connection string. And in order to get that connection string, of course, you would have to go through this guide and set it up your Azure Hub, right? I have mine set up already, so it's going to be really easy. I'm just going to copy and paste this string, and you guys are going to see the connection, right? All right. So go to Portal. And Microsoft Azure Portal looks like this. You know, we have all these services and widgets that you can hire. You can book into your hub. And you have resources over here. My resource is called the Test Hub. And on the left side over here, I have my IoT devices. And I have this one called the Plcnext Edge Gateway, which I created a while ago. And when I click on it, I have this thing called the primary connection string. That's all you need. You just hit the copy over here, and you go back to Edge Gateway and paste over here. And then you submit it. And the gateway does the rest. The reason why Microsoft Azure is so easy to get it done, so it's connected right is because we used the Microsoft Azure SDK. It's all the code we have behind the scenes over here came to us from Microsoft Azure. Same for AWS and same for Google. Okay, it's just Microsoft makes it really easy because they use a encryption key only, which is that connection string that I showed you guys. AWS and Google, they use a different security method, which is called certificates. You do not need an encryption key, but you need a certificate that is present in the cloud, and you have the same file stored in your machine, your PLC. If those files match, then the connection is successful. So that's why you have this uploads over here, so you can go get the keys for it. Okay, and these keys you're going to be downloading from your cloud services, AWS or Google. Microsoft Azure does not use that. So now publishing to Microsoft Azure is as easy as publishing to ProfCloud. You just go in as well, you add, you can pick the same analog value that I picked before. And then you can publish. So there you go. So it's publishing every 2 seconds as well. So that's about it. The last thing I really want to show you guys was Modbus, but it looks like I'm still having a problem over here. I don't know exactly what's going on. So I'm gonna open for questions as I try to fix it. So far, any questions?
Nothing in the chat, Yuri.
Okay. I just confirmed my IP address. I'm gonna try one more time. Also, one thing that I didn't cover is that we have a settings in this configuration as well, and it allows you to manage your network. You can ping to places like Google, or you can ping to a Ethernet IP device, or a Google, or a Modbus device. You can see the latency of your connection. On the top right over here, you can see whether you connected, how your CPU status is doing, how your RAM status is doing. You can use DHCP if that's the configuration of your network, right? You can also set up time zones, time servers, NTP, and you can configure your IO like I told you before. Also, let's say that you're done configuring your device and you just want to deploy that same configuration to 3 or 4 other devices. You can just come over here and download the configuration file and then upload the file in the blank device that you may have aside. That makes sense.
Yuri, Wilhelm has posted a question. Could you extend drivers like Siemens S5 or something?
Siemens S5 uses, I believe, Plcnext. So if that's the connection method you're going to use with Siemens, might recommend. We don't support Plcnext within this platform. Neither we could, because Plcnext requires a real-time system behind it. But what you can do is you just deploy your Plcnext Engineer project in here. You make your Plcnext connections to a Siemens. Then when you're ready to select the metrics you want to have from the Siemens going to a cloud, all you need to do is when you pick a source over here, you select what we call the Plcnext API. So any tag that you mark as HMI tag in Plcnext Engineer will show up over here automatically. I don't have any right now, but it will show up here automatically. Okay. Then from here, you can send to any cloud. Hope that answers your question. Same goes for any connection method that we have in Plcnext Engineer. OPC way, if you want to do OPC way, you can do that way. If you want to do Modbus, if you want to use the can open drivers in Plcnext. So Plcnext is fully operational behind this front end. Okay. No problem. So I think the last thing I'll show you guys, and unfortunately my Modbus server is not going, but I can show you that if it was working, that would be great. And all you need to do right now is to add Modbus registers or Modbus points, and it's as easy as anything you've done before. You have 4 options: coil, discrete, input, and holding registers. So you just pick a coil, you tell what is the offset for the coil, and of course coils are booleans, and then you hit submit it and it's done. And then you're gonna see your register being created over here. Hope that makes sense. If anybody else has any questions, now is the time. If not, I think we're gonna probably call it a day. And please reach out to me if you're interested on being a beta user, and we can talk. All right, I think that's it. I'm gonna wrap it up, and thank you all for being here and taking the time. Was a quick presentation, but that's the idea behind this. It needs to be easy and quick, and just notice that in probably 5 or 10 minutes, I was able to connect to two different cloud services, right? So that's how easy this device is supposed to work, this product application, and that's the idea behind it. I wish you all a nice day and a good rest of your week. Thank you.